Hi, I'm John Paul Raj, and in this video, we are going to start solving question number 1 from paper 3, May 2025, time zone 2, IB Math Applications and Interpretations. Let's get started. This question is about comparing the academic performance of two schools. All right, at age 18, all students in School A and School B take the same final exam. Augustine is studying the results of these schools. Augustine chooses to take a representative sample of size 6 from each school. Makes me wonder why just 6 students, okay? These are questions not asked, but I think as a stat student, it's important to think about all these things when you read a situation, especially if this is paper 3, right? Sample of 6 students. Is the school too large or too small? Keep that in mind. Is it just convenient sampling? I don't know. Just keep these things in mind when you're reading a question like that. For each student in the sample, he will conduct an interview. Okay, maybe it's because of the interview. I don't know. State one advantage of increasing the sample size. There you go. They've already started talking about the sample size. State one advantage of increasing the sample size. Well, he wants to study the results, right? Maybe the mean. You can say that the mean will be much more closer to the actual population mean. That's one advantage of increasing the sample size, right? Because then there won't be much variability. All right, this is just, as it is, it is 6. Immediately when I read it, that was the thing that was going in my head. So let's just write that thing down in our own words. A1, this is question number 1, right? So I'm just going to write increasing the sample size will help us determine a more accurate representation of the population mean. So basically, what we are saying is that the mean from these 6 students, there's going to be a mean, definitely, but it'll be more closer to the population mean. All right, it'll be much more closer, more accurate to the population mean. That's what you're trying to say, okay? Increasing samples, because there's not much variability. If you want to say that, because the variability will be lesser when the sample size is greater. So I think we've written a lot more than what one point is going to be. But I wrote that thing down so that it'll help you, okay? It'll help you understand the why behind it. You can just cut it short and make it a bit more succinct to answer the question. This is A part 1. A part 2 says, state one disadvantage of increasing the sample size. Well, you know what? It was in my mind. Maybe, as I use the word convenient sampling, right? Maybe, he didn't have the time. And if you're going to increase the sample size, then remember it's going to be expensive in terms of time or money or whatever that is, right? And this is a sample size. He's choosing a sample size from each school, that is also, right? Each school. So both the schools he's conducting this kind of a study. And this table that we're going to look at very soon is the table from sample from A. Okay, so this is just from A, school A. So, one disadvantage, yes, there's an advantage increasing the sample size, but there's also the practical issues, right? So we can write down that one disadvantage. Let's use the same color. Increasing, one disadvantage of increasing. Okay, this is second one, right? Disadvantage. Always try and use words from the vocabulary from the question. Okay, write it in context of what I'm saying. Disadvantage in increasing the sample size would be we'll have to spend more time, more expensive in terms of time, money, or any other resources. Okay, That's good enough. That is good enough. Okay. Think about it. If you have any other better comment, a better reason, make a note on the comment. Okay. Make sure you write that in the comment and let me know if there's a different reason you'd like. But however, having said that, this is not part of the question. Yes, we have an advantage and a disadvantage. What do you think? What would you do if you're in that situation? Knowing that this is the advantage, knowing that this is the disadvantage, what would you do? Write that in the comment and let me know. Okay, these are things that, I mean, not from an examination perspective, but I'd just like to know. All right, let's just jump to the next table now. The table in the data in table 1 shows the results of the final exam as a percentage for each of the 6 students sampled from the school A. Okay, this is a percentage. And what do we have? The mean result for the sample from school A is 51.723. So that's the mean of all these percentages. This is just candidates number and the final exam percentage. Find the value of Sn minus 1 for the sample from school A. Okay, so we're just going to use a calculator and we're going to find the unbiased estimator for the standard deviation. Okay, that's what they asked, Sn minus 1. That's what it refers to. So let's just jump over to calculator quickly and what do we have? Can I just adjust this a little bit up? There you go. All right, and I will first insert a list and spreadsheet page because we've got data. I'm just going to call it list 1. Okay, you can call it whatever you want, but be consistent, and it helps to recall the name whenever you're doing a test or something like that, to recall the column by a particular name. So remember whatever you call that. Okay, you could have called it school A. I'm just going to call it list 1. 63.5, 52.5, 50.7, 42.8, 44.7, 56.1. Okay, I've got 6 inputs there, and I'm going to conduct a 1 variable statistics. Okay, just start calculations and 1 variable statistics, and number of lists is 1. We have an X list coming from that list called list 1, and we can put our results in from column B, hit OK, and that's our mean. They had given the question, and we're looking for this one. Okay, not, can you see that? SX, this is Sn minus 1, that's the 7.6, and it might just be here, but when you click that on that cell, you'll see, you know, up to 3SF, what is it? Okay, 7.595 is 7.59 or 7.6 is good. 7.60 you should write as 3SF. That's good enough. Okay, this entry, okay, the Sn minus 1, as it says, Sx is, okay, so that's the unbiased estimate for the standard deviation. This is the standard deviation, by the way. Okay, this sigma, don't put 6.93. We're looking for 7.6. So then how do we write this answer? That's the more important thing, right? So we can come back to our question and we can say question, this is B, question 1, part B, using GDC, using 1 variable stats. So this part, just writing this part communicates to the examiner that you know how to use the calculator on the GDC. What is that value? Sn minus 1. Sn minus 1 is 7.60. Okay, just that is good enough. Typically, I ask students to write down everything, but I think this is good enough. You know, once you've said that, you know, this is what you've used, the option of 1 variable sets, that's good enough. Okay, let's continue. This says that the value of Sn minus 1 for the sample from school B is 7.66 to 3SF. Okay, so 7.60 we got for school A. For school B, they have not given the data, the data as they've given for the 6 students for school A, but they've given us the stats. Okay, so they've given us the unbiased estimate for the sample standard deviation there from school B. Then they have said that what have they said? Augustine makes the following claim. Okay, he says that the spread of results in school A must be less than the spread of results in school B. Make 1 criticism of Augustine's claim. That is what they've asked. 1 point again. Make 1 criticism. Well, you know what? 7.60. And remember, these are based on the sample. The 7.60 that we found out is based on the sample of 6 students. Okay, the population standard deviation might be slightly different than 7.60. 7.60 talks about the sample standard deviation. That's why I call it the unbiased estimate for the population standard deviation. So this is the sample standard deviation, in other words. Okay, whereas 7.66 is the sample standard deviation for school B. Again, it may not necessarily be the population, and as you can see, 7.60 7.66, it's not too far away, right? It's not too far off. So to make such a strong claim that the spread of results, and by the way, spread of any data is not just related to standard deviation, right? It can even be due to range, max and min value. So the spread of results in school A must be less than the spread of results in school B is not justified just by looking at a sample of 6 students. Another sample of 6 students might give you a different kind of sample standard deviation. So that will be our criticism. Make one criticism. So this is part C, right? Let's just write that here. Let's just draw that line and say the values 7.60 and 7.66 are sample standard deviations. Standard deviations and are nearly the same. And if you want, you can write down the difference. Okay, the difference is what is the difference? What is that? 7.66 minus 7.60 is I don't know about that 7.66 what it was rounded off to. So that's why I'm using the approximation sign. Is 0.06, right? The difference is very small. So the value is 7.60. This is the main thing. Okay, the main thing is that they are sample values. They're from a sample. They're not the population. They are supposed to represent the population. And remember, the sample size is small. So they're sample standard deviations. We call it the unbiased estimate to the population standard deviation. So they could be actually the population standard deviation might as well be equal. Okay, so I'll write that thing down. The difference between the sample standard deviation is so small, right? So you could say that the sample, the population standard deviations, standard deviation for the two schools could be or might be, could have been more closer, if not equal. Okay, this is good enough. You just want one criticism. So you just said that very clearly that, it's incorrect to say that the spread of results in school A must be less than the spread of results in school B. So the spread of results in school A might not be less than the spread of results in school B. Yes, as you can see, for 1 mark I'm writing a lot, but as I mentioned before that I was trying to explain, but at the same time I think you should find a way to write it in a much more compact way. Maybe this is a lot more than what is expected. Let me know in the comments again, okay, how would you write this argument in a nice succinct way, in a nice crisp way, but without missing all the details. I'm trying to keep it as detailed as possible, okay, because here's the thing, and hear me out, okay, open to debate here. I don't think any math teacher will cut off points or dock points because you've written a lot. I'm going to dock out points, I'm going to cut points because you wrote a lot. I think the converse is true, right? I mean, because you did not explain more steps, they might dock points. So I think it's better to be safe than sorry. So I'm not saying it's perfect. I'm not trying to justify my, I did this to explain what is going on, but definitely it could have been improved. But I just thought I'd mention that also. Nobody's going to dock points because you wrote a lot more, okay? As long as you're not repeating yourself, I think that's good enough. All right, we've done that. The examination board claims that the final exam results in each school are approximately normally distributed. That's good to know. Okay, so the the results in each school are approximately normally distributed, you may assume that this claim is correct. Okay, we are going to assume that. Augustine decides to use a pooled t-test to compare the mean results of school A and of school B. All right, so pooled t-test state the condition regarding population variances required to use a pooled t-test. Well, the condition is that the population variances must be the same, not almost the same, but they must be equal. All right. So D1, where do I write that? Let me write D here. Okay. So D, the assumption for pooled t-test, the population variance for the two schools, which is the same thing as the two samples, must be equal or the same. All right, they must be the same. Don't say that they should be almost the same, okay, because this is based on the sample standard deviation. I said they're almost equal, but if you're going to conduct the pooled t-test for the two groups, the two sample, the two schools that we're talking about, then the population variances must be equal. All right, not nearly equal, but must be equal. And variance is, related to the standard deviation. Of course, we know that there is a square of the standard deviation. So that is the condition for using the, the pooled t-test. All right, then part 2 says, state whether Augustine should use a pooled t-test in this case and justify your answer. You know what? I think he should go ahead and use, because based on our reasoning here that the sample standard deviation is nearly the same, which suggests that the population variance, the population standard deviation, and therefore the population variance are going to be identical. Okay, so in that case, I think he should use. Okay, that will be my justification. So I'm going to write D part 2. This is D part 1 and D part 2. D part 2 would be, I would say, based on what was that? This answer was C, based on the answer question 1C, since the sample standard deviation are nearly the same. And we said nearly the same because the difference, we mentioned the difference there, right? 0.06 are nearly the same. It might be true that the population, or I would say it suggests that the population standard deviation are equal. I would say population standard deviation and hence the population standard deviation variance, must be equal. So what are we saying? We're saying based on the answer to question part 1C, since the sample standard deviations are nearly the same, it suggests that the population standard deviations and hence the population variances must be equal. So what are we saying then? State whether Augustine should use pooled t-test in this case. Therefore, remember, answer in the context. Therefore, Augustine must use the pooled t-test in this case. All right, I think my writing is taking a lot longer time, but I just want it to be helpful to you all to understand. As I said before, if you think you can shorten it, if you can make it more crisp, let me know. I'd love to learn from you also. But I just wanted to be as specific as possible. It is taking a little time, which is suggesting that this is probably where we're going to stop. You're going to continue with the test in the next video. But if you found anything useful in this video, please make sure that you like and share this video with someone, and subscribe to my channel also. If you do my channel, you would probably find many other videos there. Do take a look at them. And if you have any topic, any concept, any question that you want me to explain, do mention that in the comments and I will make a video for you.